Oh, sorry. And now I'm back. So, hi, welcome to this Global Hack Week. This is the last stream before we close this beginner's week. And this is my third stream. So let me introduce myself. My name is Alberto Camarena. I'm your Major League Hacking coach from Mexico. So I see a lot of comments here. I'm so happy to be here this night for me. I don't know which time zones are you. Please let me know here in the comments. Sure. Last video stream before the closing ceremony. That's right. Johan BX is Major Hacking. Great. And some love for the Mexican flag. Thank you. Um, will be others too in the closing ceremony. Yeah, I think for let me see. Yeah, for closing ceremony, Cecilia and Alex are going to be your hosts. Um, so yeah, I hope that answers the question. Remember that it's for, well, for me will be tomorrow. For you, probably since I already seen your IST in India, um, that will be, well, I don't know what time it, but that will be 13 hours ET time. Um, Want to know my points update? Yeah, amazing. I'm really sure you're going to get your swag. Um, so let's continue. Let's start with this stream and let me talk you a little bit of why we're here. This is part three of MongoDB 101 series. If you missed part one or part two, don't worry. We are going to do a really, really quick recap, but also you can watch the recordings of those streams. Those were for yesterday and for Monday. So where you watch the streams is in our YouTube channel, where you can find our YouTube channel is in ghw.mlh.io, right? So let me share with you that link, ghw.mlh.io. And also, before I forget, I want to share with you the link for the checking in to this session. So talking about points, it's 49 points now I have. Amazing. Remember to check in so you can earn more of those points. Already checked in. Amazing. Thanks, Alberto. You're welcome. Johan Urbiax. So yeah, let me start sharing my screen, right? And then we can continue and start with this stream. What we're going to cover for this session it's indexes, data modeling, and transactions. What we covered in session one was what MongoDB is, some crude operations, and session two, also aggregations, right? So the goals of this session is that at the end you will able to explain what indexers are, when they matter, and when to create them. And we use the explain tools to compare query performance with and without these indexes, and also do a basic modeling with these patterns and best practices. Also, we are going to use the MongoDB Compass tool to validate and create our schemas, and we are going to understand the multi-document transactions and how they work. And I think this is not an entry level topic, I have to say that, but it's a really, really powerful tool once you understand it. So that's why I wanted to share it. Let's start. Yeah, I love your enthusiasm. So the recap for session one is that MongoDB, it's a NoSQL database. Remember, we have two major divisions here, SQL and not SQL. I give an example talking about that, like it's to saying if your car, it's, I don't know, for example, Chevrolet, and there are plenty other options out there. You could have a Toyota, you could have a Nissan, etc., etc. But saying sequel and non-sequel, it's just like saying you have Chevrolets and non-Chevrolet cars, right? So for the sequel, all they share the sequel or the query language um, between quotes again because they have distinctions over there. But for NoSQL, there are plenty options. You can have a key value, you can have document, you can have a graph databases, you can have many flavors of NoSQL databases. But hey, NoSQL, it's just one of the first big categories MongoDB realized. Then it's an operational database. What does operational mean? That it's the data you live and you work on every day. The other big area is for analytics, and MongoDB does do some analytics very well. They are real time or operational analytics, but not like for the big analytics. Data warehouses and BI tools, right? So that's the first thing to understand. Also, the other thing MongoDB has really well developed, it's the flexible document model. And MongoDB was again the first company to introduce this document model, and it's based on what JSON is. MongoDB didn't create it JSON. JSON it's like the web standard to sharing data, but underneath MongoDB document model uses BSON, which is just binary JSON. It extends the data typing and has some um, binary differences on how they store data, but mainly it's JSON, right? Um, we cover also what Atlas is. Remember, during the session one, we mentioned that MongoDB comes in three main flavors, which is the community edition. MongoDB it's not per se open source, but it's source available, which almost in practical terms, it's kind of the same. Um, it's free to use unless you're using it as a paid service. So that's mainly the reason how the company make money out of this. So the community edition it's free to use, and I have to say the database engine is the same for all the three flavors. The only thing that changes is the support and the tools you get to do some database management, for example, for the enterprise version and the cloud version, which is Atlas, right? We also cover Compass, which is the UI client that it's really powerful to connect, to see your data, to interact with your database, and things like that. We made use even for yesterday in Compass, the aggregation tool. It's really cool to see visually how you're building your aggregation pipelines. And today we're going to use another tool that Compass has to create our data schemas. We cover in that first some basic interactions with CRUD, like inserts and finds, and in the session, oh, sorry, and in the session number two, we get a deep dive on the update, replace, and leads. We also made queries, and we also made like fully overview on how to perform complex queries. We also see comparators for logical operations, um, sharpening these query results with the projections. Remember, it's like giving not reducing the amount of fields we want in the result with this projection, the sorting, the limiting, and the counts, and our first aggregation pipelines. What is the difference between these complex queries and aggregation pipelines? We're doing computation over the aggregation pipelines, so it's like being able to process these on the database side, right? Instead of doing that in our side. Let me see, because I see here you have some questions. Alberto, ¿qué diferencia hay entre poner retry grats true and write it majority o no ponerlo en mi URL de conexión? Um, so, for example, because David's already mentioning, you have your of connection. This connection is the standard way to link to your application DB to an Atlas cluster. Yeah, but that's not a question. Yeah, I get it. So if you take an Atlas, and I'm going to skip to Atlas here and show you uh, one point. So if I come to Atlas here, oh, let me sing it. This locked me out. Sorry, give me a second. Um, okay, yeah. If you come to your cluster and try to connect, depending on what you're trying to connect from, your URI will be different. So, for example, here, if you come to the drivers, you will see that, for example, for me, cluster that you get the basic body, right? The MongoDB plus SRE, the username, password, the cluster name, which in this case is Global Hack with Beginners, at least for me, curim.mongodb.net slash the app name, which is the cluster one again. And if you take notice, I don't have that retract rights, right? So if I go back and I try to do that with Compass, even I don't have any other thing after the slash net. It's just my DB user, DB password, cluster G beginners.mongodb.net. If I go back again and I try to do from the shell, you will see that's exactly the same. But in this case, these are some other flags that for the Mongo shell. Um, Atlas. So, for example, for the BS Code one, you will see again this is shrinked, and basically what's happening there is that in your URI or in your link, you are providing some specific things to um, the permission. So, for your example, Johan, you're saying retry writes true and write majority. So that's a preset option, and difference between adding it or not. It's giving a default setting to your connection, even though you can change it later once the connection is established. So that's no big difference. Um, but yeah, it's like setting some things by default. No one is here. Let's go to Twitch. Yeah, I think most of the people are watching this via Twitch. So thankfully, we are streaming these to both services. But yeah, if you still have questions about that, Johan, just let me know. So, for example, I think there's a resource here to check out this. Yeah, great. Um, Connection string. Oh, yeah, here, connection string. To the options one. So for example, here for the prefix, we have an SRB connection string, which is the one we are using again by default, but also we can use a standard connection string. Um, Find Atlas connection strings, options. We have options for name in case it's sensitive when using data. The option name, connection strict options, replica. For example, here we enable the replica set where using TSLs, timeouts. write connect concern options here. For example, this is the one. Write timeout in MS. The one you mentioned is retry writes. So this should be around here, but the just W, it's this corresponds to the write concerns. The option requires acknowledgement that we are writing propagated to a specific number of MongoDB instances or to MongoDB instance with a specific tags. So yeah, this is mainly that. We have plenty options. You have those available by default. De nada, y te pido una disculpa por no haber dado una respuesta más directa. Thanks for sharing that in Spanish. I am pretty sure Johanna appreciates that. Um, so yeah, let's continue with where we were. Yeah, and thanks for being so active here in the comments. I really appreciate that myself. So today, again, we're making the same workloads but fast with indexes and modeling and safer with transactions. Why performance matters? I think this is question that sorry, I got distracted by the comments. Now, this is a question that you can easily tell, okay, I kind of understand why performance matters, or just by the name, I can say, yeah, I do think it matters, but I don't fully understand why. You get it? Well, remember, I don't know if this happens to you, but at least me as a developer, if I hate something in this world, it's applications, system, web pages, or everything that I feel it's not well constructed. Um, at least here in Mexico, for me, that's why I found really, really, really frustrating when a company or an app for the government, for any other vendor, it's not responsive. Like for example, today I have to pay my cousin's school, and they asked me for help for that. My uncle asked me for help, and I enter the portal, and it takes an eternity to load. And I just think to myself, this is not well constructed. And I can understand why, if this university is charging so much for this service, they can have a really well page, right? And at least decent construct page. Um, and that annoys me. That annoys me a lot as a user. So users expect low latency for dashboards, for search, for filters, for data view. I expect, at least in all modern applications, that if I look for something in the search bars, I don't need to put the exact words, even with uppercase and lowercase, to get the result. I mean, this is not the 19th. This is the modern era. I should expect to even type I don't know if this is a search engine for music. I will expect to type the music, like how the song goes, like blah 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 blah, and I should expect to get a result and a decent one, and actually I will expect to get the song I am thinking of. So the modern user, it's, how to say that, not challenging, uh, but we demand for a lot, right? And I am pretty sure in the previous days, if you showed some feature like that to anyone, like just the capability of having the ability to search with text, that would be great. But hey, we have now the possibility to go beyond that. Um, yeah, all respect goes to the challenges and my check-ins for the streams. Um I've been using Mongoose for more than 5 years, and I think it's the best choice I've made. It's so easy, it's so quick, never fails, and those 512 megabytes keeps you literally that it keeps you never fail. Never fails. Uh, in general, I like it all. Okay, that's great. I've never been able to fit another style of DB. Um, I haven't been used to SQL or in general relational databases. It's great to hear that you made an excellent choice 5 years ago. Mongoose plus MongoDB remains the gold standard. I have my opinions on Mongoose recently. Actually, that's a great topic to talk about. Mongoose specifically, it's what we define as an document mapper of document. Sorry, let me think of this. Object relational mapper, document relational mapper, DRM. Yeah. Um, and what's about that? And we're going to talk about this deeply under the data modeling part, but I recommend not rely so much in Mongoose specifically. There's another tool that I think it's called Prisma, which it's the similar, but these are schema enforcers. It's fine, but doing an analogy, for example, if this sounds familiar to you, it's like saying TypeScript. It's the only flavor of JavaScript you're willing to do. I mean, JavaScript itself is great, and some people didn't like the flexibility and the openness of JavaScript, and they created TypeScript, which I respect. I use TypeScript, I love it, but TypeScript itself, it doesn't enforce that much. One thing I am against is that trying to turn JavaScript into high typed language. So you can do that with TypeScript really easily. And I'm not so much in favor of that. Similar thing happens with Mongo. I mean, you have the flexible document model. You can have the schema enforcer if you're okay. You want to use the schema in a more strict way. But I will say just be careful with that. Um, and yeah, about the sequel part, the same with me. I mentioned it on the first stream. I actually learned first MongoDB, or yeah, not SQL in general, and then I learned SQL, and I was like, why should I be doing this if there's MongoDB for that? So yeah, that I can relate that much to the not SQL and the SQL part. So let's continue. Um, in terms of what this slide is for, performance matters. Performance matters because we want really ambitious applications, and in the modern era, we can. Oh my god! So, what an index? No, no worries. You're not. I mean, talking with you directly here in the comments, it's worth it. I'm in love with that. Actually, this is the kind of sessions I think I enjoy the most. Like not only me talking, but actually have a discussion and a conversation here on the comments. If it was for me, I will allow you to be here on StreamYard and direct have this open scenario, but I can't imagine you here to the session. Um, but yeah, thank you so much for being so participative here, Johan and Kaustav. And if anyone else is here, like watching and wants to join more the conversation, please feel free. So, what an index is? An index is a data structure that supports fast lookups by field. We can have many types of index, but here what we're going to consider it's that even though this makes searching for information in defined operation more quick, it also makes more data. I mean, it increases our storage, and it also makes less performative the writes and the updates. Well, the writes and deletions. Uh, Hola, I see Spanish. Yeah, I think we are two Mexicans here at least, Johan and me. I don't know what about you, Fumil Layo. Where are you from? Um, how Emily knows that you are here as spectator, we don't have an option to link our Twitch account. It's enough with the check in. Um, that's a question for you, Gustav. So in the example, we can say that without an index, MongoDB may scan every document that collection to answer a query. With an index, it can quickly locate matching documents using that. And I mean, this very concept, as the documents, doesn't come from the technology itself, but it comes from life. I mean, one thing I love about the technology that we're living in nowadays, it's that this is so bio-inspired, right? And since this is actually not bio-inspired because living creatures doesn't work at this, like for example, a neural network or how a virus algorithm works. This is how we humans interact with data. So think about books. You have documents, which is like, for example, a recipe. You can have a book of recipes, and you can go all the book looking for that enchiladas recipe. But if you take a look at the first page, you will find the index, and well, at least not the first page, but the first pages. You will find the index, and in the index, you can see exactly in which page of the book the recipe you're looking for is. With the index, you don't have to go page by page. You just simply color and you have it, and that's it. Um, so types of indexes. We have single field index, for example, email, optimize queries on a single field. Compound index for status and order date, support queries and sorts on multiple fields. So that's the difference between saying the one and minus one. Multiple key indexes on array fields, for example, tags, which is of type of an array. A little hint here, they are also indexes for geospatial and specialized index. But this is not exactly what we're going to cover here. Now we are just going to use the single and the compound with sorting, right? Hello, soy Nigerian, pero hablo un poco de español y aprendo con Duolingo. Okay, that's great. That's amazing. Just curious, why you choose Spanish? That's my question. I mean, do you find any utility in that? It was just because of the culture of what the content on internet it's in Spanish. Why was your train of thought to decide Spanish is the one you want to learn? And I don't know if you speak many other languages. Oh wow, that's an answer to Johan BX from India. By the way, Alberto, I am the same. Oh yeah, yeah. I think I remember. I accept your friend request. So let's continue. When to create indexes, then when affiliates frequently using filters, I would say if you're constantly trying to find something in a read way, you should consider use indexes and in fields that you are sorting commonly. Again, remember that you have trade-offs in everything in life. So if you want an index, you will have a quicker lookup, but also you're introducing more memory size and more complex on writing and well updating in general the documents. I feel it's used in joins. So even though exactly in MongoDB there are no joins because you're not uh, stitching documents all around, you can make things like lookups, which will be similar to the join, right? Um, and then you can use an index. The balance tells us the more index helps read, but each index again adds overhead on writes and storage, which is something to consider. Not gonna lie, I just love the language. I find it lovely. What was the answer to the question? How Emily knows that you're here as a spectator? We don't have an option to link our Twitch account. Is enough with a check in. Oh yeah, for that, the answer is yeah, you do have to do the check in. Um, yeah, that was her. So let's before continuing here, let's open Compass and let's see what indexes are, right? So thankfully, we have some data preloaded from our previous streams. Remember, if you don't have this, you can just very simply come here to your cluster, and in the cluster, you can select load sample dataset and just select the one you want. I already have sample fix, which is like for movies and things, and restaurants, which is restaurants and neighborhoods. So that's the way you can get sample data really quick on Mongo Atlas. No response. Focus on the content. I already respond. Uh, maybe there is some lag. Okay, so in Compass we have one specific uh, tab for indexes, and you will see all collections come filled with one index, which is the ID. So all of these come with the ID. So looking for the ID, it's going to be always a simple thing. But what happens if, at least for example, for the neighborhoods, we don't want to look for ID, but we want to look for, well, for restaurants. Let's see what's happening here. Um, we want to look for the type of cuisine, and this could be a really simple. Let's first do something which is a grouping, right? So let's go to add a schema, sorry, an aggregation. Let's add a stage. Let's select this group, and let's group by cuisine. And okay, let me check the documents for that. Oh my god. What's happening? I just want to, okay, MongoDB docs. I want to check how this goes. Um, yeah, the revision pipeline. Okay, let me see. Group. Okay, expression. Oh my god, okay, let's see some examples. Rate that. Rating first. Some. Okay. Type of cuisine. And number. Some first rated. What happened here? Okay, maybe I need to discard this one. Again, group, field, and okay. This is going to be, what was the name of this? Type of cuisine. On this first cuisine. What's happening here? The ID of the group, the first field name. What? Okay. Sorry, I am not focusing. What's happening here? So read that rating. Let's see again this. We have ID, ABC, item, decimal quantity. Well, let's ask for this aggregation. And let's see what I was doing wrong. I want an aggregation that groups the cuisine types. Just like that. Restaurants now. Older with restaurant. and count how many restaurants are in the group. Okay, great. This is what I wanted. Um, okay, doesn't matter. So hot dogs, Bangladesh, Iran, uses with fruits, soups, all of this. And finally, we want to add a stage that sorts this to be the count into ascending. American, there's a lot of that. And finally, a stage that limits to 10. Great. So the most restaurants we have now, it's American, Chinese, coffee or tea, pizza, and Italian. These two are the same, I would say. Um, well, pizza could have many styles, not only Italian. Mexican pizza, it's one thing, right? I see another comment. Genial compa, I made a system um, in MongoDB. I don't know if you know more about that and how it works, but it works great. Multi-tenant. What do you mean with that? I think I'm not familiar with the term, but if you can share more, I will appreciate it. So we were talking about here, MongoDB 101, the use of indexes, right? So what happens if we want to look for Americans, if and we will have 6,188 results. So here, for example, we can find directly cuisine and American. No, it wasn't how it was spelled. How it's spelled. American with a capital A. So this is the results, the same, 6,183, and you can see how many times it took us. Let's do a quick comparison. Now, if we add an index and we create an index for cuisine, and we are going to add this as full text search. Let's create this. No, sorry, an index cuisine. And this is going to be ascending. Let's delete this. Cuisine text for the moment. We don't want this. So now we're going to return to documents. We're going to find it, and it was almost instant. Now, if we see here, and we refresh, this already had 2 uses. The status is ready, and we can find more things, right? What's the difference between this type of index and the one I created before? The one it's for text search, and right now we're not using that. We're going to reach that part at the end of the session. So explain, it's a tool that shows how MongoDB plans and executes the query. The key metrics are, for example, end return, how many documents we return, total docs examined, how many documents MongoDB examined, and execution time limits. Remember, the intention of using these indexes is that the total docs examined are the fewer. So in this case, if we return the exact amount that of documents that fit the search, which is again the 6,183, the number of document exams should be exact that number. It could be a little more, but we want to reduce at least as the number of documents returned. So let's put that in practice. The goal is to should be close to the document return. Remember, the goal is to do something like this. If we do a query and we do something like a plan, weight of the orders, we're going to express that. So let's go to here, to the source, examples, add a new file called index.js. We're going to copy some of these things, some just of the basics. Async function run index example, and we are going to say if require model run perfect. Now process DB, process customer, try, connect to the collection, patch, finally close. Great. So here it's where the magic happens. First things first, the database name is okay. No, the database name in this case, since we're using the sample restaurants, and the collection name it's restaurants. Yeah, exactly. So here, let's copy the example that we have. Const query says we're going to look for the, what we're going to look for, that's a great question. Let's open Compass again for cuisine American. American. We're not going to give options, any sort date, and the plan is going to say use collection that find the query, right? Oh. And we use now the .explain function that's built in within the drivers, and we give this name the execution stat. And finally, we return the documents examined, documents returned, execution time, and index used. Right, so let's run this. And before running this, we should add this to the package JSON. So here, indexes, great. Let's return to what we did before. npm run index x. Or just index. And what's our output? Documents examined 601, the same at the document return. The execution time in millisecond was 7, and the index used is fetched, right? Exactly. Now let's compare what happens if we use or if we delete the index that we were using. So let's delete this. Using number 1, let's wrap this index and let's try to perform our query again. First here, you see it is almost no difference, but if we run this again, we will realize that the numbers of document examined were too much. I mean, in this case, we are retrieving 6,183, the same and the document return here. This won't change, but the execution time almost doubled. I mean, this is still in milliseconds, but the idea here is that once you have a wider data set, one with no 25,000, but with millions of entries, well, this should be a problem, and then you should optimize with some indexes, right? So this makes this point. I think this should have it clear for what I intended to do. Sorry if I didn't make this bigger sooner, but here you will see the difference. With index, we were just examine the same number of documents we return because we already know where they are. And without index, we examine all the database and then we retrieve what we found. And this is again going page by page by page by page of the book and saying, okay, I want this, I want this, I want this. And with the index, it's I know where exactly this is, so I just return that. The execution time doubled. So even though these are milliseconds, this is the double of the time, right? Uh, and you can find this again using explain. So that's how you can be able to perform these optimizations. Index performance concept. Before I continue with this performance, let me see because I think you sent a message. Johan, yeah. Multi-tenant, it's a design pattern that serves for an unique database cluster, fits many clients, tenants in a safe and scalable way. In my case, it's a MongoDB database, and each restaurant has a collection inside that database for them, and all their documents are stored in their restaurant. Oh, okay, that's great. So you're already using this on a productive environment, I am guessing, which is great. Congratulations, and tell me, even though you already know a little bit about Mongo or too much about Mongo, what do you think about this session, and what do you think about what you're learning? Do you find it useful for your day to day, or are you planning or to take some of the knowledge you get here and put it in practice into real life? That was a great thing to share. Thank you so much. And I ask you this because it will help me prepare better my streams for other hackers here. So in the performance practice, we will choose the elastic query on our database and run without an index and expect the plan. Then create a matching index, then run the same query again and compare total document exam. So we did use something. So sorry, we just did something really similar, but in case we're going to use another tool that's called the plan from Compass. So here, this is just our examples. Uh, for an orders collection, we can have the customer, the sort, and the limit in Compass. We open this order collection and we enter the filter and we sort the appropriate without the running index, and then we run the query and click on explain. This is really similar again to what we already did. So we already look for cuisine American, and now we can hit the explain button. And what's happening here, we will see the code can return this 6,183 with the execution time of 10 milliseconds. Again, it varies 3 milliseconds for what we did before, but these help us do the query performance summary. So what we did was like in a programmatic way, we execute the code, we have our output here with console logs and everything, but this is an automated tool that helps us do it more quickly, right? So we have the documents return, the documents exam, the execution time, again 13 milliseconds. It is not stored in memory and it has no index exam. So let's create an index for this. This is what it tells us, no index available for this query. What's the insight of this? For execution without index. This query run without an index. If you plan of using this heavily, I mean, if you using again 1 or 2 times, well, there's not a problem, right? But if you want to do it like in a constant read way, you should consider create an index that covers this aggregation. Let's create this index. Let's add again cuisine. Let's say this is ascending. Inside the options, I think we didn't mention this before, but we can create a unique index, index name, create TTL, operator filter, wildcard projection, and use custom collation. In this case, just the regular one, it's okay. And while this loads, we can make sure, okay, now it's ready in the documents again on the explain one. Now the result uh, return 3 and 5 milliseconds, 8 milliseconds execution time, the same documents that return as the same documents exam, and the query used for the index was this. This it's great, and it tells us what we can do really, really simple, right? So this is the tool. Also, it has an interpreter for me option. Please confirm your request. Yeah, I confirm. The virtual assistant is thinking about that, and it will tell us an answer. Hey, query details, CT scan, fetch, perform an analysis, recommendations. There are no recommendations. This query is already well optimized for its purpose. You can use this tool to optimize your query result in here. Since we already do that in a programmatic way, I wanted to show you how to do this actually with Compass. And this is another great feature Compass has, right? I already mentioned the aggregation pipeline visualization. We have this explained. Even for the aggregation, I think we didn't do that yesterday, but today we use the AI tool they have integrated, and now we're used another one. So let's continue to that next tool I wanted to show. Um, so this is just the steps. If you want to do that again on your own, just take attention to that. Data modeling. And before we continue with data modeling, I think we have another comment from Johan. Um, I really like the sessions because even though I already know how to use Mongo, and I know the core concepts like today indexes, it never comes, or it's not. It's sorry, I'm trying to translate Johan message here. Uh, Nunca viene pulir más a detalle sobre Mongo. It's always handy to know more and to polish your skills about Mongo. Um, I realize here that it has a really great and extensive documentation. Yeah, I do agree with that, and many methods that I didn't knew. In that can come really handy for the future to optimize my projects that are already in production. Every day we learn something new, and looking at these plans, it's spectacular. I think you mentioned the planning option here on the Compass UI, right? So yeah, I agree with you. Thank you so much for the feedback, Johan. So data modeling in MongoDB, design a scheme that matches real-world access patterns, plays well with indexes and aggregations, and support transactions correctness where we need. Main tools we're going to use, it's the document model itself. We have two options here: embedding versus referencing. What's embedding and what's referencing? I'll show you with an example. So in the neighborhoods one, we have the geometry, that it's an object itself that contains coordinates and type. In the restaurants, we have, oh, let me return to the documents, an address that contains building, court, street, zip code, rates. And these all are objects that are embedded into our document. What's for referencing? Let's say for some reason, this restaurant that has a building that has some courts that have street zip code, instead of just being the regular address, this belongs to a I don't know, database for malls. That's the only case I can think of where the address is the same. So you can have many restaurants in the same address. So instead of having that repeated in each of your documents, you, instead of have that embedded, you reference that. So address will be, instead of the object, an object ID for another MongoDB document. Do we have that right now here? We don't. For the sample flicks, so for example here, the movies, this makes, I think, a lot of sense. Let's think we have director. So here, director is only a string, but instead of having a string for Thomas H. Hines, we can have an ID of the directors that we have, and that ID could lead us to another MongoDB document that is indeed the directors collection. So in the directors collection, we can have Thomas H. Hines, and Thomas H. Hines also have like the name, the last name, the age, the, I don't know, the number of movies they directed, the, I don't know, let's say prices they win, blah blah blah. We can tell that it's a full document. But what's the value then on have that as an MD document here? Well, because one director can have many movies. I mean, that's the usual, right? So here we're not connecting and we're not getting value. But let's think we have these two movies, the Civilization and the Bluebird, and both of them were directed by Thomas H. Hines. Again, if Thomas H. Hines, instead of just being a regular string, will be a full object containing a lot of information, to avoid duplication, we will be referencing this to another document. So that's the main design criteria here. Collections per domain area, carefully chosen indexes. The access pattern first design. This is something I was mentioning. Let's start with some questions. What do we need to display in the UI? The MongoDB document model has a really beautiful phrase that I want you to memorize, and that will be really simple to memorize, I swear. What is access together? It's stored together. So if you're continuously trying, for example, in the analogy of a car, that it's in SQL and it's in many tables, doing and performing joins to build again your car to show that on your UI because constantly you need to do that. Well, I think that's a problem, right? Instead of that, here you will be displaying the same information that it's in the same document, that it's constantly accessed together because it's stored together, right? So you need to answer yourself these questions. What do we need to display in UI? Which entities change together? So, for example, for the previous example, the movie and the director, yeah, it is true that if I'm going to show information about the movie, I'll probably be showing information about the director. But then the only thing I'll be accessing will be the name of the director. And then that director will have an hyperlink to then show me the director details and the full list of movies the director have directed, of course. Um, so even though this could be in two documents, these entities does not change at the same time. I could be probably updating the list of the movies the director has directed over the 5 years, over their lifetime, because a new movie was released, because the movie was released, so it's going to be updated constantly, but the previous movies won't be affected. So that could be a good design pattern to say movies live in one collection, director lives in the other, and I have specific things like design of the indexes to show for which movie this director belongs, and the other ways from each director what movies it has directed, or he or she. Um, which queries are most frequently and performance sensitive? This is another great example, and we have now the knowledge and the tools to tackle these kind of questions, right? If I'm performing like the UI mentioned heavily this query, how can I do this performance sensitive? How can I reduce the time it takes for the user to see information in the display? Um, then we choose which data should live in the same document, which data should be separated in many collections, and which fields we need indexes. And in this movie example, we answer those three. We have movies in one collection, we have directors in other one, and we have an index to be constantly accessing the name of the director, the name of the movies. In this case, we have a data sample which has not these best practices, but we know how we can implement them because we now are fluent in Mongo, right? The model should follow the application, not the other way around. That's the main uh, idea behind Mongo, right? The data adapts to us, not the other way around. We don't need to be normalizing tables. We don't need to be making things performative in the terms of bytes. Um, so data adapts to our application. Relationships with Mongo. Again, we can have one-to-one, one user, one profile, one document, or embedded. This is really simple, and this is how, for example, the relation works in in the restaurant, right? We and I mentioned it probably doesn't make sense for a restaurant that has an address which is another document, because that will be repeated. The relation is one to one. One restaurant has one address, and one address has one restaurant. There are no other ways at least even in the example I think of about the malls, where a restaurant has the same address than another. So here we used MBIF documents. It doesn't make sense to have that in another document. So relation is one to few. User with a few addresses, great candidates for embedding. So we can have an array of addresses because even though the user has few addresses, those addresses only belong to one user. Make sense? And one to many and many to many, right? To understand and products, same here, we return to the movies. You see it. One movie can have many directors, and one director has many movies. And in this case, we use references. We don't embed because otherwise we will have many duplicate data. MBF references, MBF, again, deeper diving here, it stores relate data together inside one document. It's good when data it's always acts together. It's one to few or one to one example or a document with MBF line items array. Referencing, it's used when the ID values between collections are good, when the data is shared across many patterns. In this case, again, the movie collections and the director collection, it's best example I can think of. Um, MongoDB lets you choose embedding or referencing per case. I mean, for some cases, we could have one document with embedding in the same collection that another document have referencing. And again, that polymorphism is free to use, it's flexible, and it's up to you. You decide if you manage it or not. Again, we return to the point of using Mongoose because the schema enforcer doesn't allow you to do these kind of things, which can be great or can be bad depending on you. And the best example again I can think of it's JavaScript and TypeScript. It doesn't mean JavaScript is wrong. It means it's safer. Because the application won't allow you to do things wrong, but also it's strict, which means it has less flexibility. In JavaScript, if you know what you're doing, things are going to work well. Same in Mongo. If you know what you're doing, things won't break because that's designed for that. So, yeah, again, it's up to you. Common anti-patterns. Bottom and things are sorry, what's an anti-pattern? Things that you should be aware to avoid or have in mind that are not the best practices. Button arrays that grow without limit inside a single document. What's an unbounded array? For example, I just completed a course about mentioning this. You don't know exactly how many information is going to be happening here. So this causes the document to in size up, sorry, in an uncountable way. There's a specific limit. I cannot remember the number of megabytes a document can can support, but this is not a good practice, right? Over normalizing, like in a relational database. So when it hard reads too many collection and joins, like a lookup for a single operation. This is what I was mentioning, and I have to admit I commit this anti-pattern a lot when I was recently adopting Mongo. Actually, I don't want to say they are wrong, but in my previous job we used to do this a lot, but a lot. And I mean, we didn't have the expertise. So right now, if I had to do that again, I will change a lot of things because using MongoDB as if we were using a SQL database, it's just not right. Because MongoDB actually it's designed to be more efficient than that. And I can assure you, MongoDB is faster than SQL because here we don't have disk latency. We don't have to be joining things because what's accessed together is stored together, right? And again, using MongoDB in an over normalized way, like in a relational schema, just simply makes it nonsense. And again, I have to admit, we did that a lot, a lot, a lot, a lot. Um, a lot of referencing, not too much embedding, and even we were using uh, relational diagrams and schema definitions and mongoose as if we were doing relational. And I can tell you this is an anti-pattern. It's really really frequent to see. Ignoring access patterns, designing without thinking about the actual queries and indexes. So one thing could be thinking of the data in your schema, relational way of thinking, but then not put that in practice, not checking for performance with the tools I just mentioned, and just integrate them to the application. What I have to say, another important to avoid. So the design exercise, we are going to skip it because we already did it um, with the movie and things. But hey, this is just for you, the instructions to have that in mind. Sorry, I get ahead of this. We will design a small schema using Compass. Oh well, yeah. Let's do that really quick. I mean, because yeah, I forgot to do that on Compass. So, in Compass here on the top left corner, you will see data modeling. Uh, Generate a diagram. We are going to call these in e-commerce. And yeah, we're going to use the active one. Oh, uh, give me a second. Great collection. Mm, and here, part 3. Diagram, e-commerce. Yeah, this one. The database will be part 3, and the collection name will be test. So let's generate. And let's return here. Well, we'll design a small schema using Compass, scenario, e-commerce simple style, customer, profile, information, contact details. Sorry. Orders, customers, orders, and products. The goal will be to model the collection and relationships to support typical operations, right? So for a given customer, list recent orders, see order detail. For products, look up a product by ID or SKU, show new stock and price, and for operations, product and query orders by status and date range. So what we need to do here is to propose collections, say customer, products, and orders, one product per customer, one document per product, and for orders, one document per order, right? Embed order items as an array. Relationship order customers reference customers ID. Each order item should include this one. So one example for this could be these ones. So let's insert that here on the CRUD. Cross customers. Customers. Insert one document. And so these were inserted here, the data modeling, delete, confirm. Sorry, I need to do this again. What? I thought this was on part 3. Customers, updated document. This was inserted. Wow, let's generate that and let's see what happened there. Hackers. Oh yeah, here I have customers now. I don't know. Okay. Doesn't matter. Here I'm going to add another collection. Name of the collection will be customers relationship. Oh my god, it disappeared. Okay, what other one? This will be what products? And this will be orders. Orders, get a customers. Local collection, foreign collection, customers. Local field. One-on-one. Local field, it's ID. Each order item should include product reference and price at an order. So let me return here, refresh. Export data model. What? Okay, let's see. How does this looks? No. Uh, I don't know why this is not allowing me to set more fields. Oh yeah, here they are. Okay, amazing. Yeah, my bad, my bad. So here I have a name. What else? Email, address. This is not type string. This is type object. And this first field of the object is city. And this also has a country. Now all else we have created at and this is not an object but a date. Great. You see, now for products, for orders, I mean, for orders, this is a customer ID. This is not string. This is an object ID. And actually, the relation these two has is the local field, it's customer ID. Great. And status, order date. I'm going to add the items to make this faster because we're running out of time. And this is going to be an array. And the array of this should be now the relation here. Local collection are orders, foreign collection are products, local field are items, and foreign field are the ID. Yeah. All else these have total amount. And this will be on double product ID Hey, SKU quantity. Actually, this is not a string, sorry. This is an array of objects. Well, it doesn't matter. You see, the difference is that here, this is an array of objects, and each object has the link for that. But if I want to do this right, this is not allowing me to add like another. I want to see if I remove this. Okay, now if I add here the product ID and I gave it the object ID identity, and then I return here and I add an array. Okay, now this works. Uh, Perfect. If I remove the object, those get removed. So I don't want to do that. Okay. Now it's a relationship with products to ID. Orders can have many. One product can be in many of these. So yeah, same of the customers. I think I didn't mention that. Uh, hmm. Yeah. Here, one customer can have many orders, and one product can be in many orders as well. This one, it's SKU, and what others? Name price. Yeah, price width. Okay, amazing. So, being said that, once we have that model, the next thing will be to create the database and the collections. You can also we can also use a script for that. These are the content and what's happening there, but we also define that as well already. We next thing should be create that with in a more programmable way, have that on the database and everything. But hey, the idea was to communicate. You can use this tool of the data modeling inside Compass to create this, which I think is great. Otherwise, you need to pay for something like Lucid Chart or, well, I don't know any other tool actually. I normally were using Lucid Chart in the past, which is a really nice tool. Don't get me wrong, but hey, if you already have this with Compass, why don't use it? Um, So yeah, we can save that for later. Some considerations that I didn't include in this moment. What are the indexes? Remember, where should be you looking for customers? For example, here on an email or products for SKU. The orders not here. Not only we're using the customer ID, but we are also sorting by the latest date. Same with the status, sorting by the latest date. Test queries and key keywords, recent orders from the customer. We can try to do this. This is an exercise that will be really helpful for you to replicate at your own piece at home, and try to complement these queries with some aggregations. So, really quick because we're almost finishing with this session. Transactions. MongoDB guarantees AC transactions. What does that mean? It means that it ensures uh, your data integrity. It's always all your well, it guarantees you data integrity. That's what I wanted to say. Sorry for overwhelming myself. But not only for single document, but for multiple documents operations. What does this mean? Either all of them success or all of them rolls back. And you can do this among multiple documents, but not like in the regular way how we're doing this for the update one, update many, and things like that. We There's an extra step, and I will show you how this works. Um, so some workflows you may need this document as a transaction. So, for example, Johan, that you were mentioning for the restaurants one, you probably want to update information for many restaurants in the collection, so you will be affecting multiple documents. These async multi-document transaction guarantee help you again guarantee your integrity of the data. So all of them succeed or all of them roll back, and the performance doesn't give you like incoherence. Or for example, let's say you were updating some values at some transactions, but the operation was stopped at the middle, so the remaining ones will be affected. In this case, again, you make sure that either all of them are reflect changes or none of them. Use document transactions when you need a cross-document invariant, for example, transferring points between accounts. That's for finance a great deal. Same, for example, for the documents in the restaurants example you were mentioning. I think it's really important to know this is a feature MongoDB can support, and not all people knows about this. Failing apart from the operation will leave the data inconsistent, so that's a really huge problem, right? Don't reach for transactions by default. That's another thing I would like to say and like to highlight. Many use cases can be solved with good document modeling, single document updates, but if you need to do this, start a session, start a transaction, execute the CRUD on the documents, and then attempt to commit on the error you can abort. Here, it's how that looks. You first use the session, start the session actions, create an order, await to insert in those orders, decrement the products on stock based on the second step, and this could have one, two, three, four, five, any numbers of stages that you may want, and then commit to those transactions. What happens if this fails? None of the changes above are reflected. Oh, sorry, I moved this. None of the changes above are reflected. So you have guarantee either this works or this fails, but no inconsistency in your data. So that's the big deal MongoDB can help you with. Notice how modern influence transaction needs. If most changes for a business operation happens in one document, you can avoid doing this, but you can often avoid these multiple transactions with the good data modeling, right? That's the whole point of the beginning I was mentioning. If your model splits related data across multiple collections, you may need transactions for certain workflows. So designing with both access partners and consistency requirements, it's the best advice here. And we reached the end of the session. I would like to thank you again for joining me. Please let me know on your comments if you have any questions, something you didn't understand, you want me to explain again, or if you have anything you think I didn't cover. I'll be happy to try to answer the best way possible. Today, you will learn how to use indexes, why these are important, how they affect performance, why performance is important, how to use compass and the explain functions methods inside the drivers to compare queries and take performance not only as a piece of your train of thought, but actually reviewing it and making sure you're doing the performative things at your MongoDB document database. You designed model for an e-commerce really quick. I give you the instructions on how to do that if you want again to replicate it at home, and I give you some examples and some suggestions on how you can test your abilities that you gain, not for only these sessions but for the three of them, with this last example of the e-commerce one. And finally, use compass for modeling this. Sorry, I got confused with this last step. I wanted to read the last one. You saw how to use multi-document transactions for correctness. Again, that can be achieved with the multiple document transaction that MongoDB allows, but also with a good data modeling planification. If you want further steps, in this case, remember there is a Mongo University, which you can find very interesting skills about index, data modeling, transaction, Atlas search, and many other things. So extend your workshop code. Do the examples mentioned in the slides. I gave you the yeah, I think I didn't give you the link for the repository this time. Sorry, I haven't shared that today's session. I just shared that in the previous sessions, but here it is. So here you can find all the code on all the links and everything. Also, the slides are included here on the repository. So if you want to check them later, extend your code and take some of the challenges I mentioned here. And yeah, try it yourself. That would be my best advice. Put your hands in practice. That's the best way to learn. Not only watching these streams, it's handy, but actually getting to do things on your own hands. I would say that's another great advice. Finally, again, I would like to thank you. And let me know if you have any questions. Else, I say goodbye. Thank you again for joining me. Let's see. If you don't have any questions, that will be it. Remember to join Alex and Cecilia for the closing ceremony. And well, I will see you around. Happy hacking. Gracias, Alberto. No, gracias a ustedes por estar acá. Mi placer. Yeah. And yeah, good night for all of you who are just waiting this stream to go to bed, and have a great rest of your day for those who just are starting. The ones in India, I think, the ones in Nigeria. I don't know what time is it for you, but congratulations from me here. Thank you again so much, and I will see you. Happy hacking. Bye bye.